This question is titled, if there are no variables, how do I reuse results? And what if I need one query to drive another? Because that's why I have variables in the first place. In this question, we're going to talk about subqueries. If we go to our example where we have multiple items that are categorized in some fashion, and our goal is to figure out what is the maximum value per category, there are many ways in which we can subtly change what we mean by this. We can say, what I want to do is I want to figure out the maximum value per category. Well, that's really easy. I can say select from data. Okay, that gives me everything. Let's actually select the values from the data. Group this by the category. Okay, there we go. It's going to complain, but here I'm just going to look for the maximum value per category. And I can look at the categories themselves. Oh, that was easy. The other way I can subtly express this slightly differently is I don't want the maximum value per category, which is a fairly straightforward computation. Just group by the category, compute a max. That's what group by does. All group by does is it takes your tuple space, partitioned into non-overlapping groups, and then performs a computation on each group to give you one resulting value. If I phrase this very slightly differently, and I said, I don't want the maximum value per category. I want the element which happened to have the maximum value per category. Oh, well then I'm not quite doing the same thing here. If I want each value and each row that happened to match that, then I'm no longer saying, oh, take the grouping and perform an operation on the grouping to spit out a value. I'm saying, take each group and identify from within each group the rows which happen to have the maximum value. And it seems so similar, but it is quite significantly and substantially different. I'm no longer performing an aggregated computation on these tuples. Instead, I'm performing a filtering operation. And as a consequence, I don't actually want to use the group by in this fashion because it will not be able to solve my question. We have seen questions like this before. If I have some data in Python and this data is in some sort of record form, I can ask two very different questions. What is the maximum value for this data? It would be 3. Or I can say, what is the entity which happens to have the maximum value for this data? Oh, it would be the row C, which happens to have the value 3. I'm looking for the second question, not the first question. And whereas in Python, both of these can be answered with a max. And in Python, we have a key function. To determine how we perform that maximization, there is not an equivalent in SQL to this key function approach. This is clearly a group by, whereas this requires another approach. And what you can think is it kind of requires a variable, because behind the scenes, what Max is doing with that key function is it's first pre-computing what all of the keys are and then performing the max over that. So it's first extracting the data and then performing some operation on it and then mapping that back to the original data. It's doing some kind of decorate, sort, and decorate internally. Well, if that's what I want to do, then what I could maybe do is I could use a join, like a self join. Like I could say, take the original data and join it on itself. And then if I do that, maybe group by the categories. But this seems to do something. Well, let's see what this does. This seems to do something interesting, not quite what I wanted, because here it's giving me each one of the collections of rows that happen to, it's giving me the Cartesian product of every row that had to belong to that category. And when I use that group by, what I'm thinking of is how do I take one piece of these tuples and collapse these 4 rows into one value. But I can't really do that with the name. I can do that with the value, because it would just be give me the max or min. I can't do that with the name, because the name question is give me the name which happened to have the max or the min. One of the things that's not always clear from this group by is this group by is able to compute aggregates, but it computes aggregates on the tuple as a whole, and it computes it on portions of that tuple. It doesn't give you the ability to say, give me the tuple that happened to have this value. That's a filter operation, not a computational operation. And so What I really need to do is I need to find some sort of intermediary step. I need something akin to a variable. What I'm going to do is I'm first going to compute what my maxes are for each category. And I'm going to put that into a temporary table called best. And let me remove my last query, so I'll step you through this. Here, I'll just compute, this up front, put it into a temporary table. And if I select star from best, I can see I ended up computing the best possible value per category. Now I just have to map this back to figure out, okay, what happens to be the corresponding row for this value? And that could be done with a self-join. That could be done with an inner join. I could join this best table against my original data table, and here I get all the best items. Here, let's make this really clear. Here you can see these are the original joins from my original data table. This is what I got from my best table. And then I could just filter this down to say, okay, which of these values happen to have, or which of these rows here, which of these tuples here happen to have this value. So here, I can actually do this as a group by in to a temporary table and then a self-join, or a join in this case. And so here, if I do this and I clean this up a little bit, you can see I have now each category, each row, which happen to have the maximum value for that category. And if I wanted to collapse this into just an X, Y, and Z, well, then I can force these to be distinct by doing a group by, and I can aggregate them. So you can see B happens to be the name that happened to have the max value for that category. D and E happen to be the name where there was a tie and they had the max value for that category. Or I could do something kind of hokey with this array ag. I can just select out the first value if I just wanted one of these. So you can see B, C, and D. If it's the case that I want to perform an operation that seems to move laterally across data, things that we do all the time in Python with this key function that we pass to max or min, or things that we do all the time in pandas with these index operations, in SQL, I have to break this down into multiple steps. And as part of one of those multiple steps, I have to first compute what the maximum value is, and then I have to figure out, okay, which rows match that. I have to do a filtering operation. And you can see here, instead of just saying, here's a key function, and everything happens internally, I'm actually kind of doing what that key function would do otherwise. I'm kind of pre-computing what the maxes are, and then using the self-join to perform a filtering. We wanted to talk about subqueries, however. And so what we might want to say is we want to do exactly this step, but we don't want that temporary table because it might be a little bit clumsy and we want to do this all in one query. And so what I can do is I can take that previous query and instead of joining this against a temporary table, I can join this against a subquery. I can have this query refer to another subquery as part of itself. And when I do that, I can go back to my core idea of how SQL queries are structured, and I can think. A select is all about taking some input tuples and computing things on just one tuple at a time. A function on one component of this tuple, a function on two components of this tuple, but a function on just one tuple at a time as the output. If I do a where clause, I'm basically filtering out what my input looks like. I'm saying, no, skip this tuple here, but only perform the operation on these tuples. If I'm doing a group by, I can take the result of that filtering and I can perform a function on two tuples at the same time. That's the key to the self-join. That's the key to the join. The idea of the join is I want to perform some operation on multiple tuples at the same time by joining them, by coercing them into a single tuple. And this is why you often see the self-join with the group by, because I then want to have as the result only one row for some unique key that I have here. If I do a halving, what I'm doing is I'm just filtering down the result of this group by. When I do the join, you can see I can visualize this, just perform the Cartesian product and figure out which of these that I want. And so when we think about the subquery, what we should think about for the subquery is it's the idea of going back to this core logic of the join or the from clause, identifying what the origin is, or the where clause. It's thinking about how can I update or feed the result of one of these steps back into the query, back into the from portion, or back into the inner join function. The subquery is just serving as some sort of variable to bridge multiple queries in this formulation together. And it serves almost identically the same purpose as that temporary table. The subquery doesn't really give us anything that the temporary table doesn't give us, at least from the perspective of what we're capable of doing with it. It does, however, give us the ability to write this as one single query, and it gives the query planner the ability to maybe perform some optimization so it can do some of these steps more efficiently. Then first compute this and then do that. It doesn't create an optimization barrier. If we think about it, the subquery is something very close to our notion of a variable. Here we can see that we can select the result of a subquery. We can feed one computation into another computation. If we want to use that subquery as an expression, we can even do that. We can say select from this table every value where that value happens to be equal to the maximum value where the category has to be equal to something, and this is going to turn into something very similar to that self-join situation. We could even say, do the same thing, give me all the distinct categories, and for each distinct category, select the subquery. This is something that's a little bit trickier to do with the temporary table. The subquery can serve as any expression. It doesn't just have to be the thing that fits into the from or the inner join. It can also fit into any expression that you're computing. And so here you can see I'm selecting each unique category, and then I'm doing a query for each of those unique categories. So this is another way that I could solve this problem. In fact, I can do this like this, where in this selection, I'm just referring to the category that I'm looking at, and I'm just getting the first element via some ordering. So you can see I'm not even doing a min or a max. I'm just selecting from each one of these rows some subquery, some subplan that I'm ordering and then limiting in my output. Now, would I want to do this? Probably not, because you can imagine this might be computationally expensive. It may be the case that every time it produces one new row, it's going to run that query again. And so while the subquery allows me to do this, probably not what I want to do. I probably want to do something similar to that subquery in the from or the inner join clause, not in the expression. But in general, you can kind of see this is actually being able to solve my problem. For each category, what is the row which happened to have the maximum value? Except where this is limiting is this query is running for each row of this result. This value no longer corresponds to the result of this query. This is one reason why I don't want to use a subquery like this. B's value was not set to 1. C's value, I think, was set to 3, but this is only a coincidence. What it's doing is it's just giving me the first value that it sees, the first distinct value that it sees for each of these rows, not the corresponding value for this corresponding row. It's not doing a filtering. And so, if I really wanted to do that, I'd have to do a max, and it's starting to get more and more complex. No. Let me take a big step back. What I want to do, if I want to identify what is the max value or the max row, the max name and value for each category, is I want to do a filtering. And if I want to do a filtering, then that means that I need to construct the data so that it can be filtered. If I need to construct the data so it can be filtered, what I'm going to do is I'm first going to construct the maxes, then I'm going to join so I can look at the maxes alongside each row of the data. In that join, I'm going to whittle it down so I'm looking at the appropriate max for the appropriate line of data. I'm going to look at the max for this category and the line of data for this category, and then that gives me what I want. And so when you think in the SQL way, you start to notice that you decompose these queries in a very different fashion. Just because subqueries are a variable analog, just because they're one way that we can feed the output of one query into another, doesn't mean that they're a solution to any arbitrary problem. What it does mean is they are a tool that we otherwise seem to be missing that can give us the ability to feed from one query into another. But fundamentally, anytime we want to solve one of these problems, we have to think about, is this the tool that we want subject to the way in which SQL is intended to work? And we have to go back to diagrams like this of what are each of the parts of my select statement really doing? What is it that I really want to do? Do I want to compute a value off of a group, or do I want to filter within a group? And if I want to filter within a group, the group by does not give that to me, because the group by is all about computing a value off of a group, not filtering the group down. It's very different than pandas, where pandas has group by filter. SQL does not have group by filter. Instead, what SQL has is pre-compute, inner join, and then filter. And the filtering mechanisms you have are strictly the clause on that join, the having clause, and the where clause.